Hello and welcome to Empowered Learning. This particular video is the second video in the composition function series, and in this particular video we will be talking about decomposing composition functions. And so what we mean when we say we're going to decompose a composite function is we're trying to specifically identify what is going to be our inside function and what is going to be our outside function. Okay? And so for the example that I've stated right here, given that we have a function f of g of x, of course, which will be written this way. Our g of x is the inside function, and our f of whatever the variable is would be our outside function. So let's take a look at some examples here to see how we can possibly decompose a composition function. So our first example says, let us identify f of x and g of x such that a function h of x is composed of g of x. And so of course we want to put here at the end of this that this is f of g of x, where we know the g of x is the inside function and the f of x is the outside function. Okay? So we're looking at example A, how we can easily figure out what's going to be the inside and what is the outside. We look to see what looks like it has been stuffed into something else. So we see that 4 plus 3x, all of this is being raised to the 5th power. So we see that it looks like 4 plus 3x is the thing that was stuffed inside of the 5th root function. Okay, so in this case 4 plus 3x will be the inside function, and x raised to the 5th, or blah raised to the 5th, where blah is just whatever it is that we're stuffing in there, is called the outside function. Okay. For example B, in this particular example, we see that we have x plus 3 showing up in both in the numerator and denominator. Okay, so one way that we could look at this is we could say that the x plus 3 is a thing that is stuffed inside of the x's here. So that would be, well, let me put it like this. So we'll have box minus 1 over box plus 1. And we're saying that the x raised to the 3 are the things that are being stuffed in here. So one way to think about the function h of x is just to say that the inside function is x cubed and the outside function is x minus 1 divided by x plus 1, where x again is just representing a placeholder. Okay. Moving on to our next example, C. For this one, if we look at this, we see that we have a rational expression stuffed inside of a square root. So because of that, we're suspecting that the x plus 5 divided by x plus 2 is going to be the inside function, and thus square root of blah is going to be the outside function. And wherever we say blah, basically what we're saying is a placeholder. And we use x most commonly for a placeholder. So that is why the inside function is x minus 5 divided by x plus 2, and the outside function is square root of x. For example D, we see here that clearly we have the x minus 1 inside of the parenthesis there. So of course this looks like 2 times blah raised to the 5/3 plus x times blah raised to the 2/3. So the x minus 1 is a thing that's on the inside, and if we replace all the boxes with just x's, this is what the outside function would look like. So now we're going to try some of these on our own. So the first thing that we see is that we have the function h of x, which is 1 over x minus 2. raised, all that raised to the fourth. And so here you see that you have the x minus 2 on the inside, and of course the outside just looks like 1 over blah raised to the fourth. So here we would say the inside function will be x minus 2, and of course the outside function will be 1 over x raised to the fourth. Okay. For the next example, since we see here that x squared minus 8 is stuffed on the inside of a cubic function, so we know that we have x minus 8 as being the inside function, which we'll call g of x here, and cube root of blah, and of course in the placeholder we just put an x there, so that would just be this. This would be the outside function, and that would be our f of x. And we're saying all that as if h of x is composition of f and g, where g of x is the inside function and f of x is the outside function. For example C, we see that we have 9x squared minus 4 stuffed inside an absolute value function. So here, our inside function, which we're going to call g of x, is going to be 9x squared minus 4. And the outside function, which we're calling f of x, would be, yep, that's right, it would be absolute value of x in that case. For example D, here if you notice we actually have two different ways that we can look at this. Okay, so one way, which is probably the more obvious way, is to look at square root of x minus 3 all that raised to the 4, where square root of x minus 3 is the inside function. Oops, let's clean that up. And our outside function will be f of x, which is blah raised to the 4, or simply put just x raised to the 4. Okay, where we're, in this case, we're putting x inside of the box there. Okay, so we'll just can't get it to work, so I will do it this way. Let's just erase all that, and then let's do that, and x inside of the box like that. Okay. Now, another possible way that we could look at this, although it wouldn't be a composition function of 2 functions, we could actually look at this as a composition function of 3 functions, where if we looked at the innermost function here as just being x, and then of course from there, then the next outer function would be square root of x, and then the next one after that would be all this x to the 4th. Okay, but since we just want to put it in terms of the composition of 2 functions, our square root of x minus 3 is the inside, and our x to the 4 is our outside. And for our last example, we see again that here we have x plus 2 inside parentheses. So here we would say that the inside function would just be x plus 2, and the outside function would be x cubed minus 5x plus 3, 5x squared, excuse me, plus 3x minus 1. Okay, and so of course everywhere where we see x plus 2, we just kind of look at it as a box there. And the box is just a placeholder. And our most common placeholder, again, is the variable x, or letter x. And so this concludes the video on decomposing composition functions.